Hey everyone. So I wanted to put out a quick video on how to solve circuit problems using a variation of Watt's and Ohm's law. I did release that other video, but I took it down because I wanted to make it more generic, so that you can use the laws towards different scenarios and not just be stuck in that one specific scenario that we had. I also want to release or include how decimal places really matter when you're doing your calculations. How you really need to go to 4 decimals. I hope I can do it. I might have to change our current here. Let's make it something weird, and maybe we can get 4 decimal places. But I'll show you an example with one resistor, and you can then sort of extrapolate that or expand on that and apply that to other resistors in a series circuit. The math is really like it's Lego. It's like math Lego. They're never going to give you a circuit, or I'm never going to give you a circuit problem, or I'm sure other professors are never going to give you a circuit problem where you don't have enough numbers to calculate the answers, because it doesn't make any sense, right? So you're always going to have enough numbers. You just need to slot them into the right spots and go to the right number of decimal places. I did say on the quiz it did say round, and that, from what I'm looking at, was kind of an unfortunate wording. Because what I really meant by rounding was, say you got like 1.54489 or whatever, you wouldn't round that number up to 1.54490, right? 1.54449. You would just take the number as is and get rid of that 9. You'd end up with 1.5448 in your calculations, and then for your final answer you would remove the last 2 and just take 1.54. That's what I meant by rounding. You really don't want to round the number up or round the number down, because that removes accuracy from your calculations. And the reason I say go to 4 is because, obviously you want to be as accurate as possible in calculating circuits, but it also helps for marking purposes, because if we had to figure out 7 different ways that people have rounded these numbers, it would take forever to mark, and I would probably miss stuff. So really just take 4 decimals, don't round up or down, just take the 4 in the calculations, and then just chop 2 off when you give your final answer. But let's calculate this circuit out so you can see how we can use Watt's law and Ohm's law together and interchangeably to figure out the answers to circuit problems. So in this case we had a 50 watt resistor. Well, the resistor was rated to 50 watts, or 50 watts going through it or whatever, and a circuit current of 1.25 amps. Now we know in a series circuit current's the same, so if you had multiple resistors, all you would have to do is figure out current. Current would be the key, really, for that circuit. If you could figure out current, you could basically calculate the rest of the circuit very easily, because you know that number is unchanged throughout the entire circuit. So in this case, we would take, say we wanted to figure out our source voltage, because we have one resistor in series. That one resistor is going to drop the entire source voltage. We can't have anything going back to the battery. So in this case, what we would do is we would, now this is what I do to make it easier for me to understand, but in this case, sorry, trying to figure out source, right? So we would take E, which is our voltage, electromotive force, and we go E equals, where's my I button? P, right, for wattage, over I, which is current. Right? that would equal to 50 watts divided by 1.25 amps. That would equal to, and then you do your math, 50 divided by 1.25. 40 ohms. So we know 40 ohms. We're calculating voltage. 40 volts. So our source up there would be 40 volts. Now we could calculate our T. In this case, because we only have one resistor, it'd be R1, right? And you can jump to Ohm's law. So we were using Watt's law to figure out our source voltage, because we didn't know. And then you can jump to Ohm's law, using the numbers that we have here, that we've just calculated, to figure out what our resistor is. So again, this is to make it easier for myself. I want to figure out R1, or RT. In this case it would be RT, which is the same thing as R1, because we only have one resistor. Would be equal to, and we have Ohm's law, so it would be voltage, E, or voltage, over I. In this case is current. Whoops, 1T in current. And then you could spread it out and clean this up a little bit. And this is how I write it out too when I'm doing the calculations on paper. I would write out my formula, slot the numbers in, just like, building blocks, Lego. Slot in your numbers that you have. So in this case we got 40 volts over 1.25 amps, which totals out to 32. So obviously I didn't get any decimals. It would be equal to 32 ohms. So then we'd have our 32. And you've calculated out everything that you'd really need to know about that circuit. So that's really, what am I trying to say here? Really, you'd want to just remember as well, there was a couple of places where people were using the values of one resistor, right? So say we had 10 over here, ohms, and then they were using, and then I don't know, 5 ohm resistor. They were using the values sort of together, which you can't do. Okay, you really, if you have two resistors, or 3 or 4 or however many, and you're trying to figure out circuit problems, chunk the circuit. Calculate out what you need to calculate for here, and then calculate what you need to calculate for here. Remember how current and voltage flow through circuits. Well, voltage doesn't flow, but remember how current and voltage are applied to circuits. Current in series, the same all the way through. If you have watts over here, right, watts and drop, remember drop is how much that resistor is using, you can figure out your amperage. If you figure out your amperage, you know that amperage is applied to this resistor as well. And if you only have an ohms value over here, or again a wattage value or whatever, you could then use that current that you figured out over here to calculate this resistor. You could either calculate the drop. I think you could use it to calculate, I don't remember on the quiz, I think we used it to calculate the drop. And then once you have the drop of that resistor, you could add them together, figure out your total circuit current, or your total circuit voltage. You could figure out, another way of doing it was, I believe, you could figure out the value of this resistor, and then calculating both of them together to get RT. There's a bunch of different ways you can slot the numbers in, and they will all calculate out to the same as long as you take it to 4 decimal places. As long as you don't round up and don't round down, and you should be alright. I think I'm going to release another one of these for parallel. I'm going to look at how you could calculate out parallel circuits as well. Alright, so let me put that video together, and I'll set it up in a minute. and see you soon.